Hi, Henk Akmans here, Supply Chain Dynamics, Chapter 9, Quality Cascade, Sysdea Gameplay 3, The Flow of Complaints. Uh, the flow of complaints looks small, but is rather sophisticated in its formula. And that's the reason because it's difficult to make a good estimate of how many complaints you get when something's going wrong in the primary and secondary processes. Flow complaints are really at the end of the quality cascade. So when nothing goes wrong, then why pose a complaint? This is why you see that the likely complaints come from rework. They come from the provisioning fail rate and the field install rate. So they come in our model uh, from here, from these stocks, actually from the rate at which these stocks are filled, but still from not the sunny day, but the rainy day scenarios. Um, so that's the start. Now, not everybody whose install or whose order fails files a complaint. If that, for instance, to take a silly example, if that fails, if it takes, I don't know, 5 minutes to fix, then most people won't file a complaint. And if it takes a year, then just about everybody will file a complaint or do something else. And that is why the time that it takes to fix this is actually a great driver for how many complaints are filed. So this complex formula really says, well, if it takes the actual lead time in provisioning and field install is larger than what we expect, what the customer expects, what our target is for that lead time, then we will start having complaints. And we will start having complaints according to this formula, this graphical function. So if that's just around 1.5, then some 30% of the people may be there to file a complaint. We'll see it under effect. If it's really twice as long, then just about everybody who is in that situation, that their rework is taking really long, will start to file a complaint or be ready to do that. The normal likelihood that they will do that is like 50%. So in this formula, we have the number of people who actually, here is the number of people who actually have a problem. We multiply that by how likely they are that those people might be triggered to file a complaint, and how likely they are depends on how long it takes to fix a problem. And then, even then, not everybody, but we assume just 50% of the people will actually file a complaint. Almost, because we then once more mitigate this for the effect of call handling on complaint likelihood. Because what we say is that normally, when the call center is working properly, then they can, when an angry customer calls, they can calm him or her down and make that a more likely situation, a situation in which they will not file a complaint. So with normal workloads at the call center around one, then they can sort of get 50% of the customers, still yet another 50%, not to file a complaint, but simply to sit and wait. Of course, also often because they can give you information on what's happening and perhaps even can solve some of the core problems. But the real problems are solved in this model not by call handling, but by the people in field install and in provisioning. So a number of cascades could say that try to keep complaints down. On the one, so there's problems in the primary process that lead to complaints if they last too long, and that can be made smaller or can be made even bigger by the number of people that by the workload in the call center. Node cannot be made bigger in this case, which is perhaps conservative. It can only be that all the people who would normally file a complaint when it's really busy in the call center will actually file that complaint. Now, the number of complaints pending, and actually these were the people who were so very angry sitting in the customer programs on national TV, where KPM management had to appear. These people, partly why this is such a huge, well, huge, yeah, it is huge. It's like 10% of the total population, but it's 10,000 people. Why this also became so big is because those complaints are not resolved quickly enough. And that's because of a rather unfortunate situation is that the capacity for complaint handling was limited. It was not meant to be this was a cost-driven company, and complaint handling simply costs money. So what you see here in complaint handling is that there's a maximum on how many complaints are, how many FTE the company wants in there, like 40. Given that there's a maximum, there's also a maximum allowed gap. So if there are already 40 people here, then you will not hire more. This then goes into the adjustment of the complaints handling, and it takes the smallest of these two. How many people are still allowed to be added, and how many people have I indicated that I would actually need over a certain adjustment delay. How many people do I need? Well, there we got the workload coming in. It's simply the number of people that are currently in handling times the gap in the workload. So if the workload is 1, currently 1, and that's the target workload, then there's no gap. If the workload is 2, then there's a gap of 1. If the workload is half, then actually you have there's a workload of a gap of minus a half. And as you can see from this graph, for a while there was a huge workload here during the peak, but that didn't lead to a huge increase in complaints handling, simply because there was this maximum, this cap on the number of people that were allowed. As a result of this, the capacity never got bigger than like 40, the capacity, actual capacity available to do this never got bigger than like 700, but yeah, they had like 10,000 people at some stage. So that's because of the growth. You could also look like this. We had an inflow with a maximum of 1,500. If you then can have a maximum outflow of 600, it's logical that this thing piles up. So that was a problem with complaints handling, which in the end really became the tsunami that hit KPM management.